let's say I was given a number pattern like 1, 2, 4, 8, njalo njalo. So I'm given something like this. I need to find T50 as well. How will I be able to do that? Well, the most important thing here is to know what kind of sequence are we dealing with. Is it an arithmetic? Is it a geometric? Or is it a quadratic? How do we know that? The only simple thing that we've learned is to calculate the common difference. If this is equal, then we will know that it is an arithmetic. So what's 2 minus 1? It's 1. 4 minus 2 is 2. 8 minus 4 is 4. Oh my goodness. It seems like it's not an arithmetic because we are not getting the same answer. So let's try something else. Let's try something else. How about we divide? What's 2 divided by 1? Is 2. 4 divided by 2 is 2. 8 divided by 4 is 2. So it seems like there is the same answer when we say T2 over T1. It's going to give us the same answer as term number 3 over term number 2. It's going to give us the same answer if we say term number 4 divided by term number 3. So this, ladies and gentlemen, is now known as R, or constant ratio. Constant ratio. Now with this, we can calculate whatever we need because we now know the formula that it's the pattern that it's a geometric. Knowing that is great enough. So let's calculate our A. Our A is equal to 1 because A is always first term. Our R is equal to T2 over T1, which is equal to 2 over 1, which is equal to 2. Now, when I'm calculating a geometric, and I know that so when I'm calculating a geometric and I know that I'm dealing with a geometric, I know that this is the formula that I use for the term, for the general term. I use Tn. So I write the formula right here. The formula says Tn is equal to AR to the power n minus 1. So now let's move on. We have, what's our A? It's just 1 multiplied by 2 to the power, why are we writing 2? Because our R is 2 to the power n minus 1. And when you write this, 1 will not change anything. So we just have 2 to the power n minus 1. This is the formula that we have. If this was a 3 or a 4 or any other number, we could have it left it here. Don't proceed here. Just leave it like 2 times 2 to the power n minus 1 or 3 times 2 to the power n minus 1. But here it's 1. So we know that when you multiply something by 1, it doesn't really change. So when you come here, I have the formula. So I can now calculate my T50 because I will know that this is equal to 2 to the power 50 minus 1. If we are able to calculate that, you can punch your calculator and see if it's really easy for us to calculate that, but it really seems like the number is really, really big. Okay, the bottom line here is that to understand whenever you are given sequences and series, to know when you are dealing with an arithmetic or a geometry. So the two parts that we have looked at are arithmetic and geometry. Okay, sometimes, ladies and gentlemen, we may be given that arithmetic sequence that we're talking about, but being added 2, 4, 6, 8, but this time around is given as 2, plus 4 plus 6 plus 8 plus so on and so on. This one, as long as now I am adding, it's no longer a sequence, but I'm now dealing with a series. So the series now, I use the formula S for the series. Thus, when I come here, I will look at the formulas and say, okay, fine, this formula is for the sum of the arithmetic terms. Like this was an arithmetic series, therefore, the sum of the arithmetic series, I use this formula. So next time in the lesson, we are going to cover that.